Now we are starting with the current source inverter, or that is the single phase auto sequential communicated inverter. Before this, I will recall that what is going on in the chapter 4, that is the inverter. We have the two type of the inverter, that is the voltage source inverter and the current source inverter. In the voltage source there will be a single phase and the three phase. This is the case, similar case with the current source inverter. In the single phase voltage source inverter we have the half bridge, single phase half bridge inverter, single phase full bridge voltage source inverter, and in the single phase we have single phase current source inverter. We have the single phase current source inverter with ideal switches, single phase capacitor communicated current source inverter with R load. In this we have discussed the analysis of this topic and design consideration of this topic. And in this lecture, now we're going to discuss the single phase auto sequential communicated inverter. In the three phase voltage source inverter, we have the two type of the mode, that is the 120-degree mode voltage source inverter, three phase 180-degree mode voltage source inverter. This is the similar case with the current source inverter. Now we are discussing the single phase auto sequential communicated inverter. In the short form it can be written as the single phase ASCI. The figure shows the single phase bridge inverter with the ASI. Now the description is that the current which is flowing in the circuit is the constant current source. Feed the load T1, T2, T3 and T4 are the thyristor pair switched to obtain nearly square wave output, and the capacitor, two capacitors are connected, that is the C1 connected in the upper half and C2 in the lower half. The diode, four diodes are connected in series and it is named as T1 to D4 with each SCR. Why it is connected? Because so the capacitor does not discharge into the load. Operation of this circuit will consist of the two modes, that is mode 1 and mode 2. This is the circuit diagram in which there will be a 4 thyristor and 4 diode as discussed in above, and it is the load C1 and C2, and this is the circuit diagram of the mode, how the current will flow in the mode 1. Now we will discuss about the mode 1. In the beginning, before the t equal to 0, we are assuming that T3, T4 are conducting and the current flow through T3, D3, L, D4 and T4 as shown in the figure B. It should be written, it is written as the figure A, but it is shown in the figure A. Capacitors are assumed to be initially charged, that is Vc1 is equal to Vc2 is equal to minus Vc0 at time t equal to 0. At time t equal to 0, this means that we will have to give the gate pulse, and as we will give the gate pulse, the T1 and T2 will start conducting and the T3 and T4 will not conduct. It will turn off by the application of the reverse capacitor voltage. So the pair T1, T2 conduct current through T1, C1, D3, L, D4, C2 and T2 as shown in the figure B. Capacitor start charging linearly from minus Vc0 by constant current I. The diode D1 and D2 will remain reverse biased by Vco initially. So the voltage across the diode D1, that is the VD1, is forward bias and can be obtained by transversing the closed part A, B, C, D, A as shown in the figure B. So it should become that the voltage across the diode 1 plus the voltage across the capacitor minus 1 upon C by 2 integrated I dt is equal to 0. So the voltage across the inductor is 0 because of the constant current I is flowing. So the voltage across the D1 is equal to minus Vco plus 2 upon C integrated I upon dt. As the capacitor charges VD1 across D1 rises linearly, eventually at some time T1 reverse bias across D1 vanishes, VT1 becomes 0 and diode D1 start conducting. Equation 1 hold good for diode D2 also. D1 and D2 start conducting at the same instant T1. The time for which D1, D2 remain reverse bias is obtained from the equation 1 by equating VD1 is equal to 0. So the time is come out to be C upon 2I into VCO. VC1 is equal to VC2 is equal to VC. That is the voltage across the capacitor appear as reverse voltage across the thyristor T3, T4 when T1, T2 are gated. So the value of VC, that is the voltage across the capacitor, is given as minus VCO plus 2 upon C integrated I upon dt. It will at time T1 is VC1 is equal to VC2 is equal to VC T1. So the value come out to be, so substituting the value of T1 from equation 1 in the above expression, the expression will be come out like this. This means that the voltage across the C1, C2 varies linearly from minus V0 to 0 in time t. So the mode 1 end when t is equal to T1 and Vc is equal to 0. We will discuss the mode 2 in the next lecture.